Hello. Now, last time what we discussed is the instantaneous velocity, and when you want to find out the instantaneous velocity, then you have, say, first of all, average velocity. We had average velocity is taken to be delta x upon delta t, that is change in position upon time interval. Okay, this was the average velocity, this we discussed. Okay, when we took this delta t to be very small, then it became this was average velocity. When we take this delta t very small, that is, we wrote delta t tends to 0, limit delta t tends to 0, then this delta x upon delta t, this whole thing becomes the instantaneous velocity. It is a velocity at a particular moment of time, and it is symbolically represented as dx by dt, that is rate of change of position. What do you call it? You call it rate of change of position. So rate of change of position, or time rate of change of, sometimes it is taken as time rate of change of position, is called the instantaneous velocity. Now this dx by dt, how to find, that is a mathematical process. Graphical process I tried to explain on the board, and in that we took points. Say for example, we had this kind of graph, okay, and here this time interval was taken, and this was the time, say 5 second, and the other time was 3 second. Now when you take this point very close to this 3 second, okay, if I show it by a different color, okay, then say these are the 2 points very close, then if you draw, or still close, this you can see 2 points away from each other right now, you can see, but very small distance is taken very close. Then if you join those two lines, then you get a particular tangent at a particular point, and the slope of this tangent, slope means difference of y coordinates divided by difference of x coordinate. Say if you take a b c, then slope you will get as ab upon bc, and the slope of the tangent drawn at a particular point will give you the velocity at that particular moment. Say for example, if you want to find out the velocity at this point, okay, then you draw the tangent passing through that, and slope of that tangent will give you the velocity at this point or this time, say for example some 4.2 second or so. Okay, so if you want to find velocity at a particular moment of time, then you just have to draw the tangent to the curve at that point. Say for example, at this point I want to find, then I draw the tangent passing through that point, and the slope of that tangent will give you the velocity at that moment of time. Say this is time axis and this is the position axis. If you want to find the velocity here at this point, then draw the tangent at that point, and the slope of the tangent at that point will give you the velocity at this particular moment of time. Okay, now this is the graphical method. Every time you can't use it, so we have a mathematical tool that was discovered by Sir Isaac Newton, and that was nothing but the differentiation of position. Try to understand differentiation of position with respect to time gives instantaneous velocity. differentiation of position with respect to time gives instantaneous velocity. Now how to do it? Say for example, first of all, mathematics I am right now trying to explain. If you want to find out the differentiation of, say, t raised to n, you have t raised to n. T raised to n, differentiation of t raised to n with respect to t, that can be found as, it's very easy, this is a simple formula, you have to just remember it. This n which is there on the power, this n is taken in the multiple, so n t raised to n minus 1 power is reduced by 1. This is the equation formula, you have to just remember. Now see one example I take for you. Say if it is d by dt of t square, then this differentiation will become 2. 2 comes in the multiple, t raised to 2 minus 1, that is 2 into t. Now how it has come, that you will study in mathematics when you go for your 12th standard maths. Biology students just have to remember this formula. T raised to n, the differentiation becomes n into t raised to n minus 1. This formula you have to remember. Then and then you can proceed. Then say another example I take for you. If I have d by dt of t, now this is raised to 1, so just 1 t raised to 1 minus 1, so this becomes 1 into t raised to 0, anything raised to 0 is 1, so 1 into 1, so it is 1. You can directly write d by dt of t, d by dt of t. You can directly write 1, but this is the procedure which I have shown to you. Okay. Now another, if I take for you, if I write d by dt of 3 times t square, then this is your coefficient already given, that you have to keep as it is. So 3 into, if you are taking differentiation, then this 2 will come in the multiple, so multiply by 2, that is our rule. Okay, the power has to come in multiplication. Now t raised to 2 minus 1, so this becomes 6 into t raised to 1, so this becomes 6 times t. Okay, now another one I take for you. Say d by dt of 1 upon t. Now 1 upon t is nothing but, it can be written as t raised to minus 1. Okay, so now according to our rule, this power has to come in multiple, minus 1 t raised to minus 1 minus 1, so it becomes minus t raised to minus 2. Or we can write, anything is having minus power, then you can write in the denominator minus 1 upon t square. This can be written in this way. Okay, so you can also remember, if you have say 1 upon t and differentiation if you want to find, then it becomes minus 1 upon t square. Okay, then we can have say d by dt of t raised to minus 2. This also now you can solve on your own. Okay, this can be minus 2 t raised to minus 2 minus 1, so this becomes minus 2 raised to minus 3, so this becomes minus 2 upon t cube. These all you calculate in your notebook so that you can have practice. Okay, now if you have d by dt of any number, say 100. Now if any number is there, then its differentiation becomes 0. Why? Because this 100 means, only 100 means t raised to 0 is there in its multiple. Now according to our rule, this power has to be taken in the multiple, so 100 into 0, it becomes 100. So any number you have, any constant number, without any letter with respect to which you are taking the derivative. Okay, if that number is there only, then you write its differentiation to be 0. So in general we write d by dt of any constant number is equal to 0. Okay, so now this is very clear. Again slightly more, I take d by dt of say 5t square plus 3t plus 9. Then one by one you have to take the differentiation. First you take the differentiation of first, then this 2 will come in the multiple. So this becomes 5 into 2, t raised to 2 minus 1 will become 1. 1 power is reduced. Plus 3. Now this is having 1 power, so multiple of 3 becomes 1. This 1 comes in the multiple. Okay. T raised to 1 minus 1. Okay, plus 9 is a constant number, so its differentiation becomes 0. So this becomes 10 times t plus 3. Okay, so this is very easy. You can solve this for your practice d by dt of say 5t square minus 9t plus 6. Okay, then d by dt of say minus 8t cube plus 5t square plus 9t plus 8. So this 2 can be solved by you easily, and you can get the answer of this 2 very easily. Okay, now by using these rules we have the illustration number 3.2. First of all, 3.2 is our illustration. Now before that we must understand that the instantaneous speed can be found, instantaneous velocity. If direction is there, then velocity, it is dx by dt. Time rate of change of position gives you instantaneous velocity. Try to understand. This is your instantaneous velocity. Instantaneous, this you write somewhere, otherwise velocity. Okay, and if you want to find the average velocity, then the displacement, that is delta x upon delta t, average velocity. Average velocity is delta x upon delta t, that is final position minus initial position upon the time interval in which that change in position has occurred. So this much you must understand, and then you will be able to calculate this 3.2. Now see, the position of the object is given by one equation along the x-axis. The position is given by x is equal to a plus bt square. A plus bt square. Now see, a and b are known to you, they are given to you. Say a is how much it is given, 8.5. So you can write this equation 8.5 plus b is given 2.5 meter per second square, whatever unit is given, but b is a number 2.5 into t square. So our equation is this 8.5 plus 2.5 t square. Okay, so this is our equation of position. So at any time, say at t is equal to 0, you want to find the position, then you just have to put the value t is equal to 0 in this equation. If you put it, then 2.5 into 0 square will become 0. So initial position at t is equal to 0 will become 8.5 meter, you can understand. Then if you put 1, then at 1 second you will get, okay, 8.5 plus 2.5 into 1 square, so it becomes 11. 8 plus 2, 10 plus 1, 11 it becomes. So you can find the position by placing the value of t in this equation. If you place the value of t, say 0, 1, 2 up to say whatever, then you get the position of the particle at that particular time, you get position. Okay, now this is given, again I am writing it for you. Okay, it is given by x is equal to, a stands for 8.5, so 8.5 plus 2.5 t square is the equation of position. Now the question is that the distance is measured in meter, time is measured in second, that is given to us. What is the velocity at t is equal to 0? At t is equal to 0, find the velocity. At t is equal to 0 comes when the word at is used, it becomes instantaneous value. So you must have the equation of instantaneous velocity, and instantaneous velocity can be written as v is equal to dx by dt, rate of change of position. Now you take the differentiation of this equation. So v is equal to d by dt of this equation, that is 8.5 plus 2.5 t square. Now this is a number 8.5, so its differentiation becomes 0. Then this 2 will come in this 2 which I showed by a different color. Okay, this 2 will come in the multiple. Okay, so plus 2.5 into 2, and t raised to 2 minus 1 will become 1. So the equation of this velocity becomes v is equal to 2.5 into 2 becomes 5 times t. This is the equation of instantaneous velocity. V is equal to 5 into t. Okay, so v is equal to 5t, you just write, that is the equation of instantaneous velocity. Now at which time t is equal to 0, velocity becomes, you can now easily give the answer, 5 into that value of time, that is 0 seconds, so it becomes 0 meter per second. Okay, if it is asked if t is equal to 2 seconds, you find the instantaneous velocity, then at t is equal to 2 seconds also you can give the answer. Now just you have to put instead of t 2, so v becomes 10 meter per second at 2 seconds. Okay, so you can write the values here in this way. Okay, at t is equal to 2 seconds, the velocity is 10 meter per second. At 0 second, the velocity is 0 meter per second. Or say if it is asked that at t is equal to 5 seconds, you find the velocity, then you just have to write v is equal to 5 into 5, so it becomes 25 meter per second. Okay, so at any time you can find the value of the velocity from this equation which we have derived and which we got by differentiating the equation of position. Now the next question, what is average velocity? Now for average velocity, now whenever it is asked that find average velocity, then a time interval will be given. Average velocity between t is equal to 2 seconds and t is equal to 4 seconds. So this is a time interval is given. So average velocity, as you know, it is nothing but final position x2 minus initial position x1 upon time interval, that is t2 minus t1. So this becomes your t2 4 seconds and this becomes your t1, that is 2 seconds. Now see, at t is equal to 2 seconds, that is at t1, that is 2 seconds, what is the position that you can find? X1. What is the equation of x? X is the equation of our x is position is 8.5 plus it was 2.5, then it was t square, then it was 2.5 t square. So instead of t we have to write 2. So our x1, that is our initial position, becomes 8.5 plus 2.5 into 2 square. So this initial position will become 8.5 plus this becomes 2 to the 4, okay, and this becomes 10, okay. So it becomes 18.5 meter is the initial position. So we have to find initial and final position by placing the value of the time interval which is given to us. First you write the first time, that is at 2 seconds, what is the position, okay, and then we have to now write t is equal to 4 instead of this, okay. So our initial position you got 18.5. now final position I can get x2 is equal to 8.5 plus 2.5 into t square. Now time is, final time is 4, so 4 square. So this becomes 8.5 plus 2.5 into 16, and this value will become 48.5 meter, okay. So initial position is your 18.5, okay, and the final position is 48.5. so both the values you got, okay. Now just we have to find out the average velocity. Average velocity is x2 minus x1, so 48.5 minus 18.5 divided by time interval. What is the time interval? 4 minus 2 second. So this becomes 30 divided by 2, so this becomes 15 meter per second, okay. So this way you can find the average value of velocity. You can see both the values are different, average velocity and the instantaneous velocity at different interval of time, okay. So this much you can understand easily, okay. Now whenever we shall meet, we shall further discuss about the acceleration, but these different values are showing that of velocity, that at different instant of time the values of velocities are different. So it should be noted that through average speed over a finite interval of time which is greater or equal to the magnitude of average velocity, and instantaneous speed at particular instant is equal to the magnitude of instantaneous velocity at that particular instant. Just ponder on it, remember this, okay, and we shall meet further. Thank you very much.